All right, hey Mallory, we are on 7-2. We're starting these notes today, and I told you before we started 7-1 that 7-2 and 7-3 are like the same as 7-1. Like they really are. This one is a population mean, okay? This one has a couple weird, funky things that happen to it, but it's fine. So in 7-1, we were doing proportions. Proportions. You don't have to write this down, but if you want to, go for it, okay? We were doing proportions so that we could find the confidence interval that P lives in between, right? Whatever those two numbers are, okay? And the things that we used in order to be able to do that was we used P hat, we used Q hat, we used N, and we used like the Z-score, the confidence interval, all the things, and we calculated E from all that information, and then we add and subtract it there to get your stuff, okay? So those are all the variables that we dealt with. Got it? In section 7-2, we are doing mean, and mean is average. So instead of doing a proportion, we're doing a mean, and we're trying to find the mean of a population. What symbol do we use for population mean?
Wait, population?
Population mean, mu. We use mu for mean, right? Okay. Now, what do we use for sample mean? What symbol do we use for sample mean? Instead of doing P's and Q's, we do X bar. Okay, we also will have an N, and then we also will have a Z. Some people think that this is easier because you have less variables. You have like one less variable, and the equation's just slightly easier. Okay, and I'll show you that here in a second. X bar, N, and Z, those are the only things that you need for this mean stuff. Okay, good, got it? But we are still doing the same thing. We are still developing a confidence interval, so we are adding and subtracting to find that confidence interval, right? Okay. Z is still calculated the same way we like look up at the chart, right? On this chart right here, down in the corner, and it will tell you what your Z is for 90%, 95%, 99%, that stuff, okay? That is true for about half of the problems in this section, okay? The other half of the problems in this section, you're going to use that chart that I just gave you that is, I need one, actually. I'm out of one. And it is, I don't know, black and white, I think, for most of you. But he looks like this, okay? And you are not going to use the chi side, the chi-squared side. Chi-squared has, like, the whole grid filled out with numbers. You want the side that has the bell curves on it. It says at the top, the T distribution. Do you see that? T distribution. Okay, some of you guys might have at the top it says mean, and then it says like when sigma is not known. It's kind of written really messy, okay? But I will tell you, I'll give you a like specific rundown of when you use this chart to find Z and when you use this chart to find Z, okay? There is like a rule. Like, if this happens, you use this one. If this happens, you use this one. Okay? Got it? All right, so there is that. All right. But for all intents and purposes, everything else, all of your stuff is the same. You're just adding and subtracting to find that confidence interval, and all of the things stay the same. Okay? So let's go down here and let's talk about this, right? X bar is the sample mean. You're adding and subtracting that error to find what mu is. Okay? Here is the formula for the margin of error. That guy right there. Okay? This is Z times S over the square root of N. Or T, depending on which chart you're going to use. So it's either Z or it's T, depending on which chart you're going to use. Got it? Okay? Oh, wait. We need S. Sorry, I forgot about that. Add him to your list. You need standard deviation. Yeah. We need standard deviation. Okay? For the mean. All right, here we go. Let's go down here. Okay? Here's the deal. Here is one of the rules for finding your Z-score or your T-score. Okay? In this case, they want us to find T, and I'll tell you why we're finding it on the T chart. So it says find the critical value T. This is kind of like the Z, right? We use Z or T. In this case, we're going to use T. Okay? Find the critical value T representing 95% confidence, and my sample size is 15, okay?
So you go 15.
All right, now here's the deal. Hold on. You're not going to go 15. There's weird things that happen, okay?
Or 1
You use the t-chart. Write this down off to the side. You want to use the t-chart when n is less than 30. You want to use the t-chart when n is less than 30.
And it is, because it's 15.
And in this case, the t. We don't know what the chi is for yet.
Okay.
The chi is for standard deviation, which is what we're going to do in 7.3. But we don't know what the chi is yet. So you use the t-chart when n is less than 30. If n is equal to 30, you can use the z. Okay? I'll put that down. If n is greater than or equal to 30, use the z chart. Yeah, I would. Just go off of like that information. Okay, there's one other thing that could happen that tells you whether to use the t or the z, but we'll get there. Okay, so in this case, we're using the t chart. Okay, using the t chart. We understand why, because t is less than, or n is less than 30. N is 15. Now there's one more thing that we have to do, and that is to find the degrees of freedom. Okay, here's how I just explain degrees of freedom. Are you all listening? Shh. Degrees of freedom. Here's what degrees of freedom are. Okay, and this is how I explain degrees of freedom. Okay, your degrees of freedom is always one less than what your n is. Okay, so here my n is 15. My degrees of freedom would be how much? 14. All right, now here is why you do 14 instead of 15 on the chart. We never want to assume that we can be more accurate than we are, right? We never want to assume more accuracy than what we have. So we reduce it down and we knock n down 1, and then we use that n instead, or you use that degrees of freedom instead, okay? So here's what I want you to do. Everybody get your chart out. Not the chi side, we want the bell curve side, the one that has the 3 bell curves right here. And what you're going to do is you're going to look up 14. Do you find 14 on this side? How far do you go over? 95%. So find 95% at the top. There it is, the middle column, and you're going to go to 14. It is 2.145. Everybody find it? Everybody find it. 2.145. 14 and 95%. So T equals 2.145. That is the T that we're going to use. We're not going to use 1.96. We're not going to use 1.645. We're not going to use 2.575. We're not going to use any of them on this chart because n is less than 30. We're going to use this chart. We use 14 degrees of freedom because it's 1 less than n. Are we confused?
Yes. So this goes all the way down to 2,000.
Yes. So why does it go all the way down to 2,000 if I told you you only use this chart for if n is less than 30? There will be other times and places where we do use this chart for numbers greater than 30, okay? But not for what we're doing today. Does that make sense? Yes, that's why it goes down that far, okay? Okay, so there's that. If n is less than 30, we use this chart. Got it? Yes, true. But not for what we're doing today. All right, now here's the deal. Okay, let's actually do a confidence interval. So we are actually doing the whole process, not just finding T. Here we go. Listed below are the weights of randomly selected girls at birth, and these are in hectograms. I don't know why they are in hectograms. We never measure anything in hectograms, but whatever. Like this would be like 330 grams, I think, because you move the decimal one place. I don't know. Whatever. We're just going to leave it. We're just going to leave it. Okay, so this is in hectograms. Whatever. I'm going to write this down. N equals 15. If they didn't give me that n was 15, I could count. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? N is 15. They didn't have to tell me that, but they nicely told me that, okay? They wouldn't have to tell me what X bar was, the average, because I could find the average, right? Could you add those all together and divide by 15? And if you do, you would get 30.9 as an average, okay? They didn't have to tell me that S is 2.9. What does S mean again? Standard deviation. They don't have to tell me that because you can find out standard deviation. How would I find the standard deviation from that? I would plug it in my calculator and have it spit out the formula, or like put it in a Google sheet. Do you guys remember a long time ago to do the standard deviation, we did like the sum of all the x minus mu's squared times blah, 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 all that stuff, right? Like that was big, long, and ugly, and I don't want to do that for 15 numbers. So if you're going to find the standard deviation, if they don't already give it for you, Plug it into a Google Sheet or plug it into your calculator and it will spit out the standard deviation for you. Got it? Okay, all right, there you go. So use the sample data to construct a 95% confidence interval. 95%. Okay, so here's the deal. We have to first, on mean, decide whether we're going to do Z or T. Which chart are we going to use?
T.
We're going to use the T chart. Why? Because N is less than 30. We are at 15, and 15 degrees of 15, N equals 15 means degrees of freedom is 14. And we're going 95% at 14 degrees of freedom, which we already looked up, is a T of 2.145, right? That's the T that we're going to use.
Yeah.
Okay, so ultimately what we're trying to find is where mu lives. Like, what would the population average be between, right? It is not fair for me to say that since my average with 30.9, that all baby girls would average out to be 30.9 hectograms or whatever. It's better for me to give that as a range, right? Better to give it as a range, okay? So we need to calculate the error, and the error is T times S over the square root of N. It's like way easier than the other one, right? The other error, okay? So we're going to plug in for T, 2.145 times S is 2.9, and the square root of N is 15, okay? Not 14. They're not asking degrees of freedom in the formula. They're asking for exactly what N is, okay? So now what is your error, okay? Error before, when we were doing proportion, was a number that was less than 1 because it was usually a percentage, right? Okay, error for mean will not always be less than 1. It'll be whatever units our stuff is in, right? Does that make sense? Like our X bar was 30, so I'm going to guess that our error, it might be like 5 or 3. Okay, sure, 1.6. 1.61 is my error. Sure, that's fine. We'll take it.
And then we add that to our 30 points.
Okay, so 30.9 was my X bar, right? And I want to add and subtract the error. So I'm going to add and subtract 1.61. 32.51 Hg, hectograms, or whatever that is. Okay, and if you subtract, you get
Hang on, I gotta like backtrack.
28 point, I don't know. No,
No.
29.
29.29.
29.29 Hg. Okay? So this is my approximation for all the girls in the population. Okay?
How do I even calculate degrees of freedom if we don't need it? Answer the question.
Because we used the degrees of freedom to look up the 2.145 on the chart. Right. Because that determines that 2.145. Okay? And that knocks it down just a hair, so we're not assuming more accuracy than we have. It's kind of like we're always rounding up when you're finding N. That's just what you do. I don't know. It's more in depth than that, but like that's how it works. Okay? So if we write a statement about this, we are, what's the first thing I have to include?
Ew, we have to write statements again?
How confident? We are 95% confident that if I what?
If we weigh all baby girls.
Weigh all babies. There's all, so that's the number 2.
Wait. With the girls, right?
Yep, all baby girls. Yep. Comma. I'll put comma. What?
Between
Their what?
their weight.
Their average weight, because we're talking about average, right? Their average weight would be between 29.29 Hg and 32.51 Hg. Okay, so the 4 pieces that you need, 95% confident. We need the word all. We need the word average weight, because that's telling us what we're talking about. And we need our interval. So those are the 4 things that we have to include. And our units, yes. Units go with the range. Okay? Good? Happy with that? Not too bad? Okay. All right.
Sick paragraph.
What? This is just an interpretation. We're not actually doing any calculations with this. Okay? Let's do this part and then we'll stop. Okay? We'll do this interpretation and then I'll assign you some homework. Okay? So here's the deal. Okay? I'm going to like gloss over this paragraph right here, okay? So what they've done is they have created confidence intervals for the amount of cotinine, which is like not nicotine, but it's another like addictive chemical that's found in like cigarettes and all of the things, right? Okay. So the deal here is they're measuring cotinine levels of people's blood that are smokers, that are non-smokers, that are secondhand smokers. Smokers? Secondhand smokers? Not really smokers, but anyway. Okay, exposed to smoke, okay? So here are my smokers, here are my people exposed to smoke, and here are my people who are not exposed to smoke. And these are the cotinine levels of their blood. Okay, so it's not fair for me to say that definitively every smoker will have about 176 ng per ml in their blood. It's better for me to say that probably a smoker would have somewhere between this amount and this amount in their blood. Probably depending on how often they smoke, right? Do they smoke a pack a day? Do they smoke like 2 cigarettes a day? I have no idea, right? So they're going to fall somewhere on this level, right? People who are exposed to smoke maybe will have a range looking like that. Again, probably depending on how often the people who are around them smoke, right?
I feel like if someone was just walking into like the testing center and someone was smoking outside and they were exposed to that right before, they would probably be in the same level as a smoker.
You think so?
Like it would be still high up there.
Yeah, right.
It would be higher than like normally.
Yeah, I agree. Yeah, and so yeah, that variable we would have to take into consideration. That would probably give us like a part of a false result.
Yeah.
So we would have to
They're
like.
not a smoker, but they would be up there because
Yeah,
of
right.
the fact that they were
Right,
exposed
exactly.
right
Right before, like they inhaled it as they were walking into the place. Yeah. And then these are the people who are not exposed to smoke. So maybe they just have naturally, like this would be like the non-smokers not exposed to secondhand smoke that maybe like inhaled it on the way in the thing. They would maybe live right here. I don't know. Like that's why that they have a range, right? That wouldn't just be 0. It would be like a range, right? Okay. So people exposed to smoke, people not exposed to smoke, people who are smokers, right? Okay. Then we form conclusions from this. Okay. So one of the things that we look at is like, do the intervals overlap? Do they not overlap? Like, is it an accurate statement for me to say that smokers have an elevated amount of this in their blood? Do smokers have an elevated amount of this in their blood?
Yes.
Yes, why?
Because it's higher up there.
Because this is not overlapping this. It is like that interval is entirely above the other 2 ranges. Does that make sense? So I can definitively say that those people are going to be completely elevated higher than any of the other 2 groups. Does that make sense? Okay? That is an entirely accurate statement. Now, is it fair for me to say that people who exposed to secondhand smoke have an elevated risk from people not exposed to secondhand smoke?
No, because it overlaps.
Not necessarily, because I could have a person living here and a person living here, right? Does that make sense? And this person is exposed to secondhand smoke, but this one is not, right? So it's not fair for me to say that every person who is exposed to smoke has a higher cotinine level than people who are not. Does that make sense? Okay. So forming these conclusions from this information. All right, let me just see what question they're asking. Do they have a question? The 2 non-smoking groups have confidence intervals that do not overlap, so it is possible that they have the same mean cotinine level. It is helpful to compare confidence intervals or their graphs, but such comparisons should not be used for making formal and final conclusions about equality of means. Yeah, there you go. Okay, so just giving you information. Beautiful.
Okay, so you know how cars give off emission
Yes.
and power plants give off emission? Is there any way possible that cotinine can...
I have no idea what this stuff is found in. Like what other things besides cigarettes that stuff is found in.
That's
Could
what
be,
I'm thinking,
yeah.
like, people
So
not
like that's
exposed.
like these people right here could have an elevated whatever because of like car emissions, or if they live in like New York City where you're just breathing that
Right,
in all
that's
over the
what I'm
place.
thinking, like New York City, maybe that's...
So that would explain these people. Yes. Yeah. And I have no idea. Maybe it's not found in car emissions. Maybe it's found in something else. Yes. So that would explain those people right there. Okay. What I want you to do is
I'm going to start on this tomorrow.
1, 2, what do we have here? Let's have you look at the first 4. 1, 2, 3, 4. Now, real quick, number 1. Take a look at number 1 with me.
Let's take a look.
Number one, let's talk about some things that we have up here in the top right corner. Okay? Things that we have in the top right corner. For one thing, S of X is just your S. That's just your standard deviation. Sometimes they'll write it as S of X. If you do the standard deviation in your calculator, it will write it as S of X, by the way. Okay? So that's why it's S of X. That just means
Is that
S,
our
okay?
range?
Now, this guy right here,
Use our range.
do you see that? That means that this number is 13.046 and this number over here is 22.15. They're giving it the range to you. Does that make sense?
Yeah.
Okay. So they're just writing it in parentheses, basically like an interval notation for those of you who are in college algebra and all the thing. And I guess we did it in calc maybe. Okay. But that's what this is saying right here. Okay. So when they ask you things, there is that. Oh, hey, A, express the confidence interval in the format that uses less than symbol. Given the original list of data, use 1 decimal place, round the confidence interval limits accordingly. So they want you to write this out, but use 1 decimal place. That's part A. Yeah? Okay. Then, like working backwards, calculate or find what mu is and the margin of error. So like they give you this for mu. Is that the correct mu if you're given these two guys right here?
Take 22.
Find the middle, right? And find your margin of error, okay? And make sure that these two numbers are correct according to how they have that interval written. Does that make sense? That's what you're doing, B and C. Okay? So you're kind of working backwards on number 1. But there you go.
So we minus the 17 or
Um,
minus the 16?
Don't worry about part C yet because we haven't talked about it. So just do B, A, and B.
Are we
what?
minusing the 16 or 17? If I-
No, you're not minusing any of that. You're just looking at these two numbers right here.
We have to figure out the middle, right?
Yep, figure out the middle and then add and subtract that number or whatever from what your error is.
Can you not just subtract the 2, divide by half?
Yes,
find the-
yes,
Okay.
yes, you can. Mhm.
That is what I
There's many different ways you could do it, okay? All right? Okay, you have, I don't know, a little bit of time. Start looking through 1 through 4. Don't worry about number 1, part C yet. We'll get to that in the
We
coming
know what the middle
couple days.
I'm confused.
What?
We know what the middle is.
What?
They want you to check it, though.
It's the 17 thing.
Is it exactly that number? It is? Okay.
No, I mean, not exact, but
Okay.
close.
Okay, go off of what you got when you calculated it, though. That make sense? They're wanting you to, like, check those numbers. Okay, all right, there you
So
go.
then use my new number?
Yeah, to find your E. Don't look at any of this except your region. To find your E and your X bar.
Oh, sweet. We don't even
Okay.
have to solve number 2. We just have to say whether,
Right,
whether
right.
we use Z or T.
Yeah, exactly. And what it is, right?
What do you mean what it is? We have to find an answer? Can you not just say
Oh.
Z?
Oh, no, you don't even have to find the number. You just have to say whether it's C or T. Oh, that's fancy. All right, okay, goodbye, Mal.
Come